Good morning all, it's Postbag. And let's start with this one. And it is a little module. Yes, it's a boost converter LED driver. 2 pots. Ooh, that one's got a bit bent over. Let's take a closer look at this. So yes, this is an LED boost converter, or an LED driver. It has both the voltage and the current potentiometers. They would have to be set up manually. You can't of course short the output of a boost converter, so we'd have to put an ammeter in circuit with that. So V in here, red and black leads, big Schottky diode there, an SS56. Now if memory serves me right, that's a 5 amp 60 volts I think. 4 caps, all 220 at 50 by the look of it. 2 more Schottky diodes down here. Now I was hoping, very interesting, that the toroid inductor is sitting on top of this MOSFET, I guess that is there. It's also glued down onto what looks like either a 14 or 16 pin chip, and you may not be able to see it, but someone's scraped the markings off the top of the chip, which is a nuisance because I was hoping to see if this thing could be modified for pulse width modulation, brightness control. So here's the item on eBay. This is a DC-DC boost converter, constant current. It has the 2 potentiometers, mobile, power supply, 250 watts, which is what interested me. These things are always overrated, so certainly conservatively you could run this at 100 watts, I would imagine. 10 amp LED driver. It's $4.70. Tiny amount of shipping, $1.25, and this is from Juri, China. Now there are some specs on this listing down here. So what do we have? Input voltage anywhere from 8.5, oh there's a flashing background, that's annoying, 8.5 to 48 volts. Output is 12 to 50, adjustable. Output current is 10 amps max, but here's the caveat. Please enhance the heat dissipation if more than 6 amps. Well, for a 100 watt LED, we're looking at 3 amps, so we should be able to run it without enhanced heat dissipation. Output constant current is 0.2 to 8 amps. Please don't short the output to adjust the current. Can't do that on a boost converter. You can on a buck converter, but not boost because of the topology. Conversion efficiency is 96%. Here, I wonder whether it really is that, because this is not a synchronous DC to DC converter. This one uses a Schottky diode, and there's a few other bits and bobs here, including size. Now the PCB isn't fiberglass. You can see that it's a solid piece of aluminium, and then on the top we've got presumably insulating layers, this white stuff, and also tracks you can see in there. So there's a head start with the heat dissipation because it's essentially solid metal. Now because it's metal and not fiberglass, you can't really drill holes through it, so the through-hole components here, these 2 potentiometers, have been mounted rather crudely as surface mount devices, which is why this one had got knocked over. So I've bent that back. Those connections do look okay, but if there's any problem with this, I might suspect that first. So I've just lifted the toroid here, which may or may not have been a good idea, because I think I've just stressed that joint there, which again is a surface mount type joint. And you can see here that the chip, it's actually a 16 pin chip. I mean, it's possible that it's a microcontroller, in which case you don't really need to scrape the markings away because nobody knows what the code is inside. But if it's an off-the-shelf boost converter chip, I don't know which one it is because it's all been scraped. So the idea with this is that for general 100 watt LED applications, this is my LED project board. I've got a 100 watt LED on the front of this computer heatsink here, and I've always used this type of driver, which is similar in that it has 2 potentiometers to adjust the voltage and current. This is supposedly rated at 600 watts, but it's quite a big chunky thing, so this thing will replace it. That's it, size for size. And this thing rated at 250 should still be fine for driving a 100 watt LED. So this is where I want to try this. At some point I will replace the big 600 watt one with this 250 watt one and see how we go, see how warm this thing gets. Okay, next we have this one. Let's see what's in here. And it's that lot. Let's have a look at that. And this has just made me laugh because this is extraordinarily tiny. What we have here, there's a Arduino, what's that, a Nano in there. I'll come back to that. I've got two stepper motors here. They're sort of a bit more than stepper motors. Let me get in a bit closer. I was thinking I've never really done anything with motors, and stepper motors are the most interesting kind of motor, of course. So I bought these, and I bought these because rather than just have a stepper motor with a spindle going around and having to stick tape on it to see that it's even doing anything, I thought these would be quite fun. These are stepper motors with linear actuators. So the shaft has a spiral on it, and this one has a sort of handy plastic thing here with a couple of screws in it. That's got quite a nice action. But this one, I didn't realise it was so tiny. It's absolutely microscopic. Let me get in even closer. So this one's so small I'm having to use low-tech macro mode with my magnifying glass here. See if I can bring the pencil in. Yeah, so it's absolutely minuscule, tiny little threaded rod there. There's a little plastic bush on there, so you could attach something to that, so that will move backwards and forwards. I'm just going to turn the unit upside down because I just noticed that you can see the coils of wire in there. Absolutely tiny. How many connections has this thing got? Actually, I think it's 4. Yeah, I think I can see 4 there. Let's get in even closer. So this is low-tech super macro mode with 2 magnifying glasses. And yes, you can just about make out that there are 4 connection points there. So it's definitely a stepper motor. Let's take a look at that plastic moving part, see how you can anchor something to that. Well, you're not going to be able to attach much to it. Let me just see if I can move it to see. But it's just mounted on the threaded rod there, and it rotates, but of course it's got that long arm which would stop it rotating so that it would move up and down that shaft. Now you can see from the markings on my cutting mat, which are 1 centimetre square, that this thing's only about 2.5 centimetres long. Yeah, so the small one, the thread is about 2 centimetres long, and then the motor extends out a little bit from that. The bigger one is, what's that, 3, 6, 7, 7.5 centimetres for the spiral rod, and then there's the motor as well. Let's see if there's any data on these on the eBay listing. So here's the bigger one on eBay. This is described as a B04E drive stepper motor, screw plus A-nut slider, small stages DIY. Quite a few of these have sold. People are interested in these. $2.81 free shipping. This came from CZB. Oh, what's that number? 672 1960. Was he born in 1960? We're guessing. Now it says, note, this is a used item, and on closer inspection, yes, it does look like it's been used, but I'm sure it'll be fine. Now we've got some data here, 6 volts for the coils, so we can experiment just sticking a battery on there just to see what happens. 30 RPM is the revolving speed. Well, of course, you can make the revolving speed whatever you want, subject to the motor responding to the pulses, so we could experiment with running it slow, running it fast, seeing when it's smooth and when it's resonating and making a horrible noise. And the much smaller one is called a 2-phase 4-wire. Now, I don't know a lot about stepper motors, so I'm going to do a video where I just play with this. I'll probably use Kevin Darrag's approach, where he just stuck switches on it and pressed the switches in a certain sequence to try and get the thing to move. Stepper motor, micro stepper motor, it's certainly micro. with slider track DIY. This is just $1.47, no additional shipping on top of that. This is also CZB 6721960. I will get used to that name in due course. Okay, data for this one is, what's that? Phase resistor, so 30 ohm coils by the look of it. Voltage is 5 volts. Note about the small motor, we don't have more information. Please know that before you do the purchase. Well, I don't mind. I'm happy with that. Very nicely packaged, this Nano, in a sort of metallized bag with a caution label on there. Let's open it up. So I just needed a few more Nanos. I found that I've only got one of these CH340 Nanos. I'm not using the FTDI or fake FTDI ones anymore. They're just too much trouble. So there's the CH340G chip and the 5 volt regulator there. And on the other side, of course, the ATmega 328P microcontroller, 16 meg ceramic resonator, or maybe crystal, we're not quite sure which one it is, a switch, 4 resistors and 4 LEDs. And finally the Nano Arduino from the same seller. Again, these things are just getting cheaper and cheaper. This is a CH340 type Nano, version 3.0, 5 volt, 16 megahertz clock, microcontroller board. Just $2.66, no additional shipping on that, and that is again from the same seller. And so there are today's Postbag items. Cheerio.